Good morning.
Morning, Professor.
Yeah. Okay. I think I mentioned it last time that we're gonna schedule a test after I finish the chapter 7, the objects and the classes. I think this is a very important chapter. So when we say Java is object-oriented programming language, we actually mean that using Java, we can create an object. Okay, so we can actually define the behaviors and of the object. We can define the attributes of the object. The attributes can be defined using field variables. The behavior can be defined using the methods. Okay, so we can pretty much create a class, and then we can create a various different objects for the class. So we expect to have, I expect to spend actually 2 more classes, probably including this one, for chapter 7. And then after the chapter 7, we're going to schedule a test, our second test. Okay. So if you actually look at the syllabus, you may notice that the syllabus is not really accurate. It's just for reference, because we have a couple of delays due to the snow or for various different reasons. So that's why if you look at the syllabus, we're supposed to have a test today, but syllabus is just the schedule on the syllabus is just used for reference only, because the actual schedule gonna be changed. Okay, so just to let you know, so it's most likely going to be scheduled on next week for the test one, probably like a Friday next, this coming, not this coming Friday, not this Friday, but next Friday. Okay. Okay, so let's continue to talk about the classes. We actually mentioned a couple of things about the classes. We first actually talk about how to create a class, how to create a field variable for the class, and how to create methods for the class. And we also mentioned that when the class is created, when you try to create an object for the class, then we can actually call the constructors for the classes. If we actually define a constructor, then the constructor will be called. Now, if we don't explicitly define a constructor, a default constructor will be called, and the default value will be initialized for the field variables. And sometimes we can define one constructor, sometimes we can define 2 constructors, or we can define multiple constructors using the constructor overloading, which is very similar to the method overloading. It's actually the same as method overloading, because constructor is actually a method, but it's a very special method. So when you create a constructor, you only say public space, then the class name. The constructor is the method for the constructor basically use the class name. Okay. Now with the overloading, we have to make sure the signature for each of the constructor is different. That means the parameter listers should be different. Okay. So that's something we just talked about. And we also mentioned that in Java, we allow to use one of the particular parameter called this. This is implicit parameters. Normally, this is basically when we define a class, and when we define a methods, when we define variables in a class, this basically means this class. Okay. So it's either defined used as the something called object references. So if we define object for the class, and this basically means this object, And also, this can be used to represent the class names. For example, in the constructor, if you call another constructor, then you can, instead of actually put the constructor name, you can put this. Okay. One of the example we used last time was, say, let me actually. Okay, so for example, if we actually define a constructor for the bank account, and we can say public bank account. So remember, we define one of the constructor that allow us to initialize, create a bank account object and provide the initial amount, right? So the first one is double, that's the initial amount. And the second one is string, and we can provide owner. And then, so we can say balance equals initial amount. And the account owner equals the owner. Okay, so we create a constructor that allow us to create the object and also assign the initial balance and the account owner. So let me actually show this. And so in this example, we just mentioned that we can use this to emphasize this bank account. Okay, so that means balance is a field variable for the class bank account. So then we emphasize this balance is actually field class. So then we put this dot balance. In this case, this basically means the bank account. Okay, it's an object of the bank account, object of reference object, and then this balance is the parameter. Okay. So, however, we can use this and it works fine, but I still as a good the good practice, we should avoid to use the same name for the field variable and the parameter. So it's not recommended. So I still actually recommend that you use the different than say initial amount instead of balance, because balance is used as a field variable. Okay. But in terms of syntax, we can do that. But the only thing we need to do is if we put this dot balance, now we can tell the difference between this balance and the other balance. Okay. Like this account owner and the other account owner. This dot account owner means the field variable, and this account owner means the parameter. Okay. But again, as I say, it's not a good idea to use the same name. So I prefer that we change this one back. Okay.
And Professor, what would happen if we didn't have this dot balance? If we would just balance? Would that? I'm trying to understand the scope of the field variable.
Yeah.
Oh, can we not see it because it's private, or? No, wait, that's for outside the class.
Yeah, it's for outside class. Then, but you just remember that if I use balance here, right, and use balance here, that balance is the reference. That's a parameter. Okay. Now, if we actually say Do you ask the question like if we eliminate that one, right?
If yes, but if the one on the parameter was named different, would it refer to, because don't member methods have the same,
Now,
aren't field
because
values?
if the field variable is private, then you cannot directly say the object, object reference dot that variable name. You cannot do that. For example, like say my account dot balance. You cannot do this from the outside, not from the inside. The inside is still okay. If inside the class, you can use that.
But doesn't this? I'm trying to remember the scope of variables, and I thought, and maybe I'm misunderstanding this, but I thought the scope of a variable, like of a field variable, includes member methods, or is that not correct?
The field variable includes the member methods. That's correct. Okay. So that means if the field variable like a balance is defined as a private as a field variable, so this balance can be used inside the member methods, but not outside. For example, if I try to use like my account or this dot balance, like this dot balance, if I use this in the statical methods, then it will give you error message, because statical method is not a member method. It's regarded as outside the class object.
Okay.
Is it clear? I know this is actually kind of very actually confusing topic, right?
I think I'll get the hang of it as I see more of it and use more of it writing my own code.
Yeah.
Thank you for explaining that.
Yeah, because if you define a field variable, that field variable can be referred inside the member methods. When I say inside the member method, that means it's a method without a statical keyword. So that means it's the method that can be referred using the object. But if you use statical, the statical method does not belong to the object. Okay. So like a main method, it's not, you cannot say this dot balance in the main method. Main method is a statical, method. Okay. So just remember this can be used inside the class bank account, but not include the statical method. The statical method does not belong to the inside of the class. Okay. Okay. Now, so today we're going to talk about another tough topic. Okay. We're going to talk about the primitive and the reference types more. Okay. Remember, so we actually mentioned that the primitive types, basically, a primitive type of variable directly stores the data for the variable types. Okay. Now, like integer, like int, double, character, char. So for example, what does it mean is that if I define an integer x, y, okay, and then Java will actually reserve a memory location for x and reserve a memory location for y. Now, typically, for integer type, Java going to reserve 32 bits. Okay, 32 bits, which basically it means like 4 bytes memory space for x and y. So that means there's a limit that in terms of what's the largest number you can represent using the int type. Okay, it's 2 to the 32. That's probably the largest number you can represent. Okay. Now, when you actually say assign a value to x, 20. Okay. So then 20 will be directly copied to the space reserved for x. And when I say y equals x, so that means I'm going to copy the value stored in actually x to the space reserved for y. So I'm going to copy this value. So that's a primitive type. So you basically directly store the value of this type of this variable in the space reserved for this variable. Now, when we talk about the reference, okay, now remember that we have so far we have talked about various different reference type. For example, string is a reference type, right? And the class is also a reference type. That if we declare a class like a bank account, that's if I declare my account, my savings account as a bank account, then my account and my savings account are reference variable. Okay. Now let's say if I declare a reference variable, okay, say string x, or I use a. I don't want to confuse with the other one. And also I can define a bank account. Say my checking. Okay. So in that case, the Java going to reserve a space a for a space for a, and also reserve a space for my checking. Okay. Now that space is fixed size. Now how much? Now unlike like int, we reserve like a 32 bits, but for these reference, I don't know how much space that Java going to reserve. Depend on the memory address system you use. If you use 32 bits for the memory, then Java reserve 32 bits. Sometimes the more advanced computer system use 64 bits for the memory. Then you reserve 64 bits because this space is reserved for memory address, and we call it reference. Okay, that's a reference. Okay, now so at this moment, actually Java reserved a space for a, which is a reference space, and also reference space for my checking. Okay. And these spaces are basically the same for every reference variable, whether it's a string or bank account or object. Basically, it's the size of the memory address. Now, when I actually assign a value, say a equals I am a student. And then the Java gonna actually find a memory location, and then store the value I am a student somewhere in the memory location. But Java gonna remember will actually record the memory address, okay, and store this memory address over here, the value over here. So if the memory address is 1000, that value 1000 will be stored here. Now I use 1000 because it's just coming to my mind. The actual reference value, Java will actually keep it from the user. So you will probably not know what is the reference value unless you really want to type the reference value, which is kind of like a very strange number, right? Because it's a memory location. Okay. So you don't want to know. So I use 1000 for easy for easy understanding. Okay. So once you actually create the object and store the value, and then Java gonna actually just record the memory location for the object and in the reference space. So in another word, we say that the A is actually pointed to the object. Okay. A is pointed to the object. Now, same thing with bank account. So if I actually create my checking account, which is a reference to the bank account type, and then when I call using the new bank account, and that's the constructor, right? I can call the constructor. So I can call bank account. We define 3 constructors. You can call any of the constructor. So let's say I'm calling the default constructor. So for the default constructor, remember we assign the balance to 0. We assign the account owner to John Doe, right? So that's my that's my checking. So this is this same as my checking. So when Java actually, call the actual constructor to create the bank account, my checking account object. Okay. So then Java going to reserve a space. So Java is not going to, store the value like a balance, my account owner, the account owner, and all this different method in that space, because that space is too small to store an object. So Java going to create the object and store the object somewhere in the memory location, and in that object, you store the balance, right? So which is 0.0, because I call the default constructor, so the balance is 0, and the account owner is, sorry, I'm running out of space, but the account owner is, what is the value? It's John Doe, right? And then there's some other actual method that defined in the object. And Java also record the reference for this object. And I say the reference is 1500. Okay, so basically 1500 is stored in this reference variable. Okay, so this reference variable does not directly store the value for this object because this object is too big, but it's stores the reference value for the object, which is the memory location for the object. So basically my check is pointing to this object. That's important. Okay, remember, it's important to remember this. Okay, because next time I'm gonna try not to confuse you further, but you are still probably going to be confused with the problem we have. Okay. So now, so there are 2 primitive type and reference type. But in certain case, Java wants to, create a special type of classes. Okay. These classes are called wrapper classes. Okay. So the wrapper classes are built-in reference types that augment the primitive types. What does that mean? That means that for each of the primitive type, like int, double, char, or any other primitive type, Java wants to create the corresponding reference type. Okay. One of the examples is like for integer type, but Java wants to create an integer type as a reference. So Java actually, in the library, Java define another type called integer instead of int. Now, int is a primitive type, but integer is a reference type. It's called a wrapper class of int. Okay, so in Java, I can declare a variable called integer, and then I can declare integer x, and then I have an int x, or I use int y. Okay. Now, what's the difference between x and y? Y is a primitive type, so that means the value of y is directly stored in here, right? But integer type, if I declare x as an integer type, or I use z, because I have used x and y here. Now, if z is an integer type, so that means Java gonna reserve a space for z. Okay. Now, once Java declared integer type z, and I can use the z just like any primitive type integer. Okay, so I can say z. So it's okay. Let me actually change to next space. If I say integer z, and then Java gonna reserve a space the z. Okay. Now remember the z is a reference type, so it's actually the z is integer is a class. So z is a reference, is an object to the integer type of class. Okay. So, however, when I create this z integer, this is called a wrapper class of integer, int. Now, if I define int x and y, what's the difference between x, the y, and the z? Now, I can say they're different. Definitely, they're different, right? Z is an object, so it's a reference variable. X, Y is a primitive reference, a primitive type. So X, Y. So when I say X equals 20, so I basically reserve, when I declare X, X reserve a space. And then when I assign 20 to X, I put a 20 over here. So however, when I actually declare integer z, so I reserve a space for z, and that's reference. Okay. Now I can still use the z just like a primitive type, but remember it's not a primitive type. So I can assign z equals 20. Okay. Now remember, z is a reference type. So I'm not going to actually copy 20 directly in this space. So the Java going to reserve a space in another place. Okay. Now with the value called 20, and then that space is going to store more information, because with the integer class, Java actually define many methods, member methods for the integer type of class, for the wrapper class, because it's a class, it's not a primitive type. Primitive type is just a space for storing value, but the reference class basically going to refer to an object. Now you can put a lot of stuff in the object, so the value is just 1. When I say z equals 20, so Java actually reserve a space, stores object, and this object has a value 20, but they also store many other parameters. Okay, and then put a reference value, that's a memory address. Let's say 500, that's a memory address. So the z actually stores 500. So 20 is the value, in the object that the z is pointing to. Listen to this again. 20 is the value which is stored in the object of integer type. 20 is the value that is stored in the object of integer type, which is pointed to by z. Okay. So when you use it, you don't see the difference, but in terms of the actual storage, x and z are different. So in another word, the Java gonna take more memory space to store the wrapper class z instead of the primitive type. Okay. And to make things even more confusing, if I declare two integer, the wrapper class integer, and I call the z1 and the z2, comma. So I reserve this, if z1 equals 20, then I reserve a space and then put the z1 over here. Okay. So z1, that's z1. Okay. Any questions before I move forward?
Are you using the integer class just as a simplified example, or is there really ever a reason to use an integer as an object like this?
That's a good question. That's a good question, because you may ask, if the integer class is gonna take a lot of more space and then use just like a primitive type, why you want to create an object, right? Yeah. We're going to talk about this later, because later on we're going to talk about something called the wrapper, array list. So eventually we're going to create an array of variable size, because right now when we declare the array of a primitive type, the array size is fixed. You cannot actually define a variable size array. But with the wrapper class, with a class, you can declare an array of integer, and that array, the size of the array can change. Okay, so that's something we can talk about later, but at this moment we need to realize the difference between these two, the primitive type and the corresponding wrapper classes. Okay, so let's say if I actually do z1 and z2, both are a wrapper class integer, and then if I say, okay, I continue with this code. Okay, x or y equals x. So both x and y are primitive type. So if I say y equals x, so basically, so I'm going to assign the value, copy the y value of x to y. So y also gets 20. Correct? That's the easy part. Now what about if I say z2 equals z1?
Would that change the reference?
That's correct. So when you declare integer z1 and a z2, so z1 is a reference and z2 also defined as a reference type. When I do actually z2 equals z1, that means the reference value of z1 were copied to the reference type field of z2. So you copy the reference. Okay. Now this basically means z2 also points to the same memory address of z1 points to. So you basically, when you assign this, you are not actually creating two objects. You are still use the same object over here. So both z1 and z2 are basically pointing to the same object. Okay. That's the difference between y equals x and the z2 equals z1. Now, however, if I declare another integer type of Z3, and I put to say Z3 equals 20, now that means I'm going to create an object which stores the value 20, and the Z3 will pointing to that object. So that means if I create another one, then I'm going to create another object with the value 20 and with all this information. And then I create the Z3 is a reference, and that reference point to this one. And this reference definitely going to be different from 500, right? It could be like a 1,000, okay, say. And then Z3 is 1,000. So now you see the difference between, Z2 equals Z1 and Z3 equals 20. So Z2, basically, I don't create another object. So Z2 going to point to 2. A Z2 basically just point to the same object as Z1 point, that Z1 points to. Now Z3 is different because I assign a different value. No, I basically assign the same value, which is also 20 as Z1, right? I assign the same value, but this value 20 actually stored in a different object. Then so that means, so this is a different object, okay? Even though the value is the same. Even though the value is the same, okay? Just remember this, because I hope you remember this concept before we move forward, because the next topic is going to be even tougher. Now, using the reference variable of a wrapper classes can also be compared using equals and compare to. Now, what does that mean? Now, people are going to ask, when I say reference variable, remember Z1, Z2, Z3 are reference variable. They are basically integer type, right? Now, if I actually write a statement to say if Z1 equals Z2, and then I can do something, okay? And else, I'm going to do something else. Now, in this particular scenario, what is the value for this comparison? Because that's basically, it's like a logical value. When you compare two, it's a works fine for primitive type, okay? So if for primitive type, if x equals y, so let's say y equals x, so the value of x and the value of y are the same. So if I say if x equals y, then we then do something. Now, what's the value for here?
It's the actual integer, like if 20 was the one you used in the last slide.
So 20 compared to 20. So this is true, right? The condition is true, right? If x is 20, y is 20, condition is true. Now, if you compare Z1 and Z2, what do you think? Is it true or false?
I think it's false. I believe you're comparing the memory addresses.
Okay. In this case, I think it's still true because Z1 and the Z2 both has a reference value to 500. Okay. But just remember, when you compare Z1 and the Z2, when you compare using double equals, you are actually comparing the reference value, the memory address value. Now, in this case, it happens to be both Z1 and Z2 are 500, right? Which is fine. So this is going to be true. Now, what about if I say Z1 and Z3? Z1 contains 500. Z3 contains 1000 because we talk about the reference value. So even though Z1 and Z3 basically they're pointing to a different object, but these different objects has the same value 20, right? So, but even though the values are the same, but they are different objects. So the reference for Z1 and Z3 are different. So when you use comparison, Z1 and Z3, so basically you got a false.
And this is why you can't compare strings with equals equals, right? That's why you have to use the equals method.
That's true because string is a reference type. So when you compare, say, let's say, that's a good question. So I say string equals x, like I have 3 strings, x, y, z, right? And x equals say Brady, and y equals x, and z also equals Brady. Okay, sorry, z also equals Brady, and then you will see that the x equals y, and the x now x compared with y, you will get true for this case because y equals x. So basically you copy the reference value of x to the reference of y. So y and x has the same reference value. So that means y and x points to the same object. Okay, so that means x, y, they both point to Brady, even though they're two different, but they have the same reference value, right? So you compare x and y, that's true. But you compare x and z, it's different. You got a false, right? Because when you create a z equals Brady, so you could create a different object which stores a string value Brady, and z point to another one. So z and x has a different reference value, right? So if you really want to compare, so mostly when people write x equals y, they basically mean they want to compare the value that the string variable points to, right? But this is not going to serve the purpose using double equals. So in order to compare x and y, you need to use the method called equal to. Okay, so in this case, so x dot equals z. Now this is going to give you the true because both the value that x points to and the value z points to are the same. Both are Brady, right? So they're true. But not using double equal because the double equal only compares the reference. Same thing with z1, z2, z3. So if you want to compare z1 equals z3, if you really want to compare the value that each actually reference variable points to, which you want to compare 20 to 20. So if you really want to compare the values, then you should use instead of this, you should use z1 dot equals z2. Oh, z3. Also z2, because even though z1 and z2 are points to the same reference value, if you really want to compare the value 20, not the reference value, just the value that the reference actually variable points to, then you should use the function call z1 dot equal, which the equals is a method which is defined in the wrapper class, whatever the wrapper class is. So in this case, z1 and z2 are basically integer, the wrapper class called integer. I'm going to stop it right now. So I'm wait to see whether you have any questions on this, because that's important. You have to actually understand this part, because otherwise you will feel like, wow, lots of strange things happens. Why these things happens? Because you basically confused with the value that the reference variable points to, and the value the reference points actually stored, the reference value itself. Okay. The reference value is the address of the object. Okay. And the value is actually the reference variable points to. That's the actual object. It's different. So let's say if n1 and n2, so when you compare, you should use, you should not use this one. If n1 is the wrapper class of integer, n2 is a wrapper class of integer, so you should use num1 dot equals parentheses num2, not num1 equals, because this will compare the reference value of num1 and the reference value of num2. Now, if num1 and num2 points to the same object, so they have a same reference, then it will shows, oh, the value is true. Eventually that's true. But if num1 points to one object, the num2 points to the other object, then the value going to be false, even though both objects actually has the same value. Okay, but they are different object. So basically corresponded, so which basically represented by different reference values. So num1 and the num2, if both num1 and num2 reference the same integer object, but do not compare the integer's content, which is 20 in our case, the Z1, Z2 case. The 20 is the content. Okay. So if you compare the contents, you use the methods like equals, compare to. If you want to just compare whether both actually reference variable points to the same object, that means both reference variable has the same reference value, then you can use this. But typically people don't use this for reference, because this is confusing. In a lot of time, people are going to mess up with these comparison. They believe, oh, I'm comparing two streams. Okay, y x equals Brady Chen, y equals Brady Chen, and x equals y. Why you got false? I'm confused. Well, it is confusing because you are comparing the reference. When I say x equals Brady Chen, y equals Brady Chen, basically the Java created two different objects. Both objects stores the value Brady Chen, but they are different objects. So the reference value is different. Okay. Now, if you really want to compare whether x has a value Brady Chen and y has a value Brady Chen, you use x dot equals parenthesis y. Okay. I hope that's clear enough. Any questions? So Java has the primitive type int, double character, char, and the long for long integer type. And then Java also create a corresponding wrapper class for it. So integer type int is corresponding to integer. Double is corresponding to double. So you can see that mostly they just actually, change the first character to capital. Okay. With the exception that the integer not use the int, use integer the whole word, but double is already a whole word, so it's used for cow, it's used cow, lamb, it used lamb. Okay, so now these are the wrapper class corresponding to the primitive type. Now it's interestingly, so when you actually declare wrapper class and so you can actually use the wrapper class as same way as the primitive type. So you can say x equals 20 and the y equals 10. Okay. And you can even say, so integer y and z, and you can even actually do this, like a z equals x plus y. You can actually use this wrapper class and the primitive type or its corresponding primitive type interchangeably in the arithmetic. Okay. So that's basically, so in that case, when you actually do this, say x, which is an integer, the wrapper class, plus y is a primitive type, right? X is in this case, Java can automatically convert the wrapper class x to a primitive type. That's called auto unboxing. Unboxing basically means change the type from its wrapper class to a primitive type. Auto boxing basically means when you declare a method, when you declare a primitive type x, and then you automatically convert it into a wrapper class type. Okay. So in this case, when you actually do this, so x is a wrapper class, so you're gonna do the auto unboxing. So it's automatically convert the wrapper class object to a corresponding primitive type. Because when you do the arithmetic, like addition, multiplication, subtraction, these actually these actually operations are only defined for the primitive type, not for the wrapper class. But you can still perform these operations because of this auto boxing and unboxing. Okay, so auto boxing and unboxing so allows people to use this wrapper class and its corresponding primitive type, make it easy to convert, interchangeably. So they can just easily convert back and forth. So people just feel like, oh, wow, even though I define the wrapper class, I can still use them just like any primitive type. Now that's an illusion because it is actually not a primitive type. So this comes to the next question people may ask, just like the question that Tyler asked, why why you want to create a wrapper class if the primitive type can serve the purpose why you want to create a wrapper class. That's something we're going to talk about later because there's a reason why people want to use the wrapper class. Okay. And also for the wrapper class, there are many different methods that are defined, allowing people to do the conversion. Okay. Now, if you say I have a integer, I have an int. So to convert an integer, the wrapper class integer, to an int type, then you can pretty much use the auto boxing and the unboxing. But sometimes you want to convert a different type. Now here's the example. num2 is declared as double. The value is 6.76345 or 43. Remember, just notice that this D is a capital D, right? So it is a wrapper class. So num2 is actually a reference variable. Okay. Now for the reference variable, then you can use all the methods defined for reference variable. So one of the methods is called int value. Now int value is actually used to convert the double into an integer. Okay. So, but because this num2 is a wrapper class, so you have to call a method to convert it into integer. So this is going to return 6. You're going to get rid of the fractional part. So only keep the number 6. Okay. So that's the int value. And double value allows you to convert the other type into the double type. Okay. So num1 is integer type. Okay. But if I say dot double value, so I'm going to convert a num1, which is 14, to 14.0. So because I convert it into double. And I also can convert into long type. Okay. So num3 is a double, which is actually 5.6 times 10 to the 12. That's used the scientific notation, but for long value, I can convert into extend this into I don't know, 5, 6, how many zeros? That's 5.6 to the times 10 to the 12, right? So this actually methods are created to allows you to convert back and forth between different type. Now for primitive type, remember, if you want to convert a type, what do you what do you use? What kind of approach are you going to use?
Would you cast it?
You can use casting or use the assignment. It will do implicitly. If you assign a double value into an integer value, you can actually convert implicitly. But you can also explicitly do the conversion by using the casting, saying, okay, 6.2, I just say, so let's say x equals 6.2 if it's double, then y is integer. Okay, so then I can say y equals int x. So I actually use the casting to force the double variable x to be an integer value and assign to the integer type y. So you can use the casting for explicit conversion, but you can also use the implicit conversion just by assigning the double variable to an integer variable, or assign an integer variable to a double variable. And this way, Java gonna do the implicit conversion. But with the primitive, with the wrapper class, you can use the class method. Okay, that's additional overhead. But as I said, there's a value for the wrapper class. So we're going to talk about this later. Now, also, let's talk a little bit more about a string. And our string is also a reference variable, right? So you cannot compare the string with another string using like a double equal. So this gonna only compare the two actual string variable, the reference value of two string variables, not the actual value that these two string variable points to. Now string has two actual additional methods. One is called a toString. Okay. Now toString is actually a method defined in an integer and also the other wrapper classes like integer, okay, or double. So then So if I use, declare num1 as integer, and I call num1 dot toString, this is going to convert the value, integer value, to a string value. Okay, so in another word, num, even though it's a wrapper class, okay, but the value for the wrapper class is 10. But if I use toString, I'm going to convert actually this into a string, number 10 as a string, not a value. Now, this is one of the application for the wrapper class, because you cannot do this for the primitive type. If the primitive type is, I have say x, so int x equals 10. Now, if I want to actually convert this integer type into a string type, you cannot do this because it's a primitive type. There's no method you can call to convert this method. But now, if you convert into a wrapper class integer, then you can call a method called a toString to convert it into a string. This is good. Okay. Okay, there are some more methods. So if you take a look at this, and you can search to the Oracle website and check the Java string class, you can see a lot of, or integer class, you can see a lot of different methods, allows you to manipulate these. Because if you define a wrapper class like an integer, even though x is a value 10, because this is actually defined, and you have a lot of methods associated with it. So x is a reference that point to this one, right? So then you can manipulate the value using all these methods. Okay, so that's why it gave you more option to manipulate the value. But for the primitive type, you cannot do this. Okay. And the next topic we're going to talk about is the array list. Now, that's a reason why we want to create these wrapper classes. You have a primitive integer int type, you have a primitive double type, you have primitive count type. Why you want to create a wrapper class? Because wrapper class allows you to create something called ordered list, okay, of reference type. And ordered list, you can create a list like a, so if you want to create a list like 1, 12, 13, 7, 5, 6. Okay. Now people are going to say, oh, if you want to create a list like this, you can use array, right? Yes, array. For array, you can create a ordered list of integer. But you will find out array is not really flexible, because you cannot change the size of array. Once you declare an array, you have to specify the size. Say array int, array type. So x is array, a new int, and you have to specify the value here, 100 or whatever. You cannot put the variable here. Say, I want to define the array of variable size. I don't want to tell you what's the size, because I don't know how many elements I want to actually define for this array. No, you can't. You cannot do this. This is not really flexible, because, for example, you want to define a list of students in the class, and for each semester, the class size is different. Okay. Now we talk about the one actually workaround. The one of workaround is, well, the class size is different, but I can declare an array of element 100. So, okay. So the 100 is the maximum capacity for the classroom. So the classroom can accommodate up to 100 students. So I declare an array of 100. And then I can use the array, only use small number of elements in this array. So I can use the student 1, 2, 3, 4, and I declare the student list all the way to 100 elements. Okay. So I can declare a string of array of string. So I say student. $100. Okay. Now, but we find out when we actually use this array, mostly we only use like up to like 20, 25 elements. So we're never going to use 100 elements. But when you declare this array of string, then the Java going to reserve that much space to store it. But you don't actually use 100. So to resolve this issue, one of the approach you can use is create array list. It's all the list of reference type that comes with Java. This is a special type. Now each item in the array list is known as an element. It's just like array. Okay. When you actually use the actual array list, you have to, in the import statement at the very top, you have to import the java.util.arraylist. Okay. Here's the declaration. You're going to declare array list and okay, it's angle bracket. Okay, and put the integer here. This is the variable val, which is array, like array, but it's actually array list. Okay, it's not a array, it's array list. And then array list integer parentheses. See, you don't actually specify what's the maximum number of array list. You don't have to specify the number of elements for the list, just like this one. Okay. So this basically creates a reference variable val that refers to the new array list object. Now, here I put the integer here. So that means it will eventually create a list of kind of wrapper class integer. So it's actually a list of integer value. Okay, but this inside thing can be replaced by any objects. Okay. So I can even define, say, array list bank account. And say accounts equals new array list bank account. So then I can create a list of bank accounts. So I can manage all these different bank accounts. Okay. Now, the good thing about array list is array list size can grow. Okay. So you can initially create an array list with 0 elements. So that means there's nothing in there. It's an empty array list. And then you can use called methods of the array list to add element into the array list. So for example, I create the bank account called accounts. So then I can add accounts, the first account, second account, third account. So I can create a list of accounts. Okay. Just keep that in mind the array list does not support primitive type. Array list does not support primitive type. So something you can say array list int. So my list equals new array list int. That's wrong. Okay. This will give you error message because you try to create array list of primitive type. That's not a very good approach. Okay. So we don't actually support this. Okay. I think I'm gonna stop right here. So there's plenty of material you need to absorb because first you need to understand the difference between. I think the main thing you need to you know the difference between the primitive type and the reference type. Okay, and then next thing you need to understand is for each of the primitive type, int, double, cal, whatever, there's a corresponding wrapper class. That the wrapper class basically defines the reference variable, which is corresponding to each of the primitive type. And then the wrapper class can be used just like a primitive type, but the wrapper class has a wrapper class has many methods defined in it. You can actually manipulate these class value. Even though like an integer, it's a wrapper class, you can say x as is a wrapper class in wrapper class integer type, and then you can say x equals 20. So even though it looks like x equals 20 like an integer, but this x is an object, so it says its value is 20, but then there's a lot of methods defined for this x object, so you can manipulate this thing. Okay, I think that's the things you need to understand. And also what I want is, so after the class, I'm going to post some of the questions, some of the code. And I want you to look at the question. And so I hope you still remember your team members. I want you to have each of the team to discuss the questions I posted on the Blackboard discussion forum. Okay, so I'm going to do this today. So hopefully tomorrow, you're going to see the questions I post on the Blackboard discussion forum. So I hope that each team going to discuss my question, and you can post your answer, create a thread after this, and or you can bring up the questions in the class on Friday. Okay. Okay, I think that's pretty much all for today. Do you have any questions?